everyone. If you are just joining me, we're just kicking off like a couple minutes late today, 3 minutes. Welcome if you are if you're joining. This is kind of part 4. So we'll start off recapping the last couple of sessions. I know that we didn't stream last week. So we've been Dockerizing our web app that we stole from Randall Hunt. And then hi to everyone saying hi in chat. Thanks for joining me. Epic. Is there echo? I'm in like an office, so it might be a little echoey. Hopefully not too bad. So recapping the last couple of weeks. First, we talked about how to Dockerize our app. So we wrote our Docker file a couple weeks ago. Yes. So I think there's probably is there latency? Hang on 1 second, and we'll see if we can fix it. Awesome. So I think hopefully fingers crossed that I'm back. If you're just joining us or if you've stuck around this long, sorry for the problems. We are having some difficulties, and then OBS crashed my whole computer. So that was fun. Hopefully people hear me now or see me now or any of the above. I guess just shout in chat if you are having problems with the stream or hearing. Hopefully it's not too terrible. It's really hard to tell. In any case, if you've been, whether you've been hanging out for the last couple of weeks with us or whether you're just joining today, hopefully, okay. I'm hearing that there's maybe still a strong echo. I wish I knew a little bit more about how to fix it. But I do not. Give a presidential speech. I don't know if I know any presidential speeches. I kind of wish that I did though. That might be fun. Yeah, I guess if anyone has any suggestions on how to fix echo, I'm into it. I guess we will just power through for now, unless we should maybe try again. I don't know why it's bad. So I already checked. And I believe there's only the single audio channel. But I could be wrong. Possibly. Gina says maybe your sound is looping. I am not an OBS expert, so I'm not really sure. Hopefully someone knows. That someone is potentially not me. I am fooling around with some OBS settings, so we can see if we can figure some of it out. But I don't have a solid answer at this moment. I am going to maybe be back in a couple minutes, and I'm going to see if I have some fix this. I will be back. Can anyone hear me? I'm possibly back. I think I just wasn't talking before. I'm waiting for my video preview to show up again. It's kind of hard to test Twitch by yourself. Okay, so hopefully people can hear me. If you're still here, super sorry about the delay. We're not really sure what's happening. I have no idea how OBS works. It is a mystery to me. So hopefully we can figure out what happened and then we can improve in the future. So if you're just joining or if you've been hanging out waiting for me to get my technical act together, welcome back. So quick recap of what has been happening in the last couple weeks. I know we didn't stream last week on our Docker app, but we've been working on Dockerizing a web app that we got from our friend Randall Hunt. It's an app called Is the 7 Running? It just returns yes or no, the 7 turn is not running. So week 1, we learned how to write a Docker file and we talked about some basics. So how do I build and run my Docker container with just my little Python application in it. Week 2, we talked about pushing and pulling from remotes. So we created a registry in ECR, which is Amazon's container registry, and we pushed our app to it. And then 2 weeks ago, so our 3rd week, we talked about doing all of our AWS setup. We talked a little bit about security groups and task definitions and how to create our cluster. We're going to take it a little bit further this week, and we're going to try and deploy our task definition, which I don't expect will work correctly the first time because I always forget something. Today will be a little short today, by the way, guys, since it took us so long to get up and running, but hopefully we can just kind of fly through it. In any case, we are back in business, so let's take a little look at where kind of everything is hanging out for us, and we can see if it's right or not. So we have our Twitch cluster. There's nothing happening in it. We haven't tried to deploy anything. We have no instances running. We have no services. So we talked a little bit 2 weeks ago, which I keep calling last week, but I was at DockerCon, which was also really fun, by the way. Highly recommend. If anyone is looking for a cool conference next year, you should try that. They had inflatable whales, which I really wanted one, but it turns out you can get the same inflatable whales online. So then I didn't have to put in my luggage. In any case, so we have our cluster. We talked a little bit last week, though, about how things in ECS have to happen in a pretty specific order. So when we tried last week where we tried to create our we tried to create our service, and we couldn't until we had created a task definition. And then we tried to create our load balancer, and we couldn't do that yet either. So things in ECS have to happen in a pretty specific order. So we have to do some stuff here to make sure that all of our setup can happen just the way we want it to. So we're going to open a couple tabs because I love tabs. So you can tell that I haven't done any of the stuff since last week, which is fine. So if our console loads, cool. So we have our console happening right now. So we have our container service, and then this is pretty much where we made it to last week, right? So we tried to create a service, and then it said, okay, well, you have to configure your load balancer, and then you have to do your auto scaling. So we created our task definition last week. So if you guys can see here, I'll make my font a little bit bigger. So you can see our Twitch MTA task definition. We're not sure if this is going to work yet, by the way. We're going to call this 7 train. So I only need one task here because I don't really expect that there's going to be any traffic to it. But because I'm a reformed ops person, we're going to have at least 2 tasks, not 22, Abby. We talked about a lot of these options last week. If you're looking for a quick refresher, we can set the minimum and maximum percentage that we need to be healthy. So we can do like a little version of rolling deployments. This is basically just letting you deploy without using additional capacity. So I don't need to use extra. I'm basically replacing them all in place rather than starting up a bunch of extra ones. We talked a bit about task placement policy last week also. It's going to default to this AZ balanced spread, which means that between all the availability zones where we have a cluster instance, it's going to try to distribute those tasks evenly across those availability zones. You have a couple other options here. There's some of these are new. There's kind of two ways that you can kind of use this. And there's a little AWS thing right here saying that you can optimize for both availability and efficiency. But what this means really is that if I'm spreading, I'm going to try to distribute them evenly across all my different availability zones. If I'm bin packing though, I'm trying to go for the most efficient use of resources. So find the cluster instance that has the least amount of available CPU and memory and allocate that task there. What this means in practice is that, so previously, you kind of defaulted to this AZ balanced spread. Well, kind of. But basically, you would place your task kind of anywhere on that cluster, and it would spread them out between instances, but it wasn't necessarily the most efficient use of resources. So I might end up with one instance that had 3 tasks, and then 2 separate instances, each with 1 task. So I'd have 3 instances, one with 3, and then one with 1 each. But what if I didn't want to pay for 3 instances? So instead, now I can use bin pack, which keeps my resource usage as efficient as possible. There's also something that I was really excited to see, 1 task per host. This is really great for logging and monitoring and stuff like that, where you want to make sure that each each instance in your cluster has one and only one copy of that task running. So really good for stuff that you need to make sure is present on each ECS box, but that you don't want more of. Like a New Relic agent or a sumo monitoring or logging or something like that. You can do custom here also, so you can write your own strategies. We're not going to do that here because we don't really need to, but you can. So this is just a demo app, but if you're running a production cluster, you might have some stuff. You might want a more custom task placement policy, and that's okay. So I definitely look into the documentation. I learned out how to write some more complicated ones. We're going to stick with the default. That's, I think, kind of the big AWS takeaway for a lot of things is that if you don't know what you're doing, or if it's a topic that you don't know a lot more of, you're usually pretty safe with the defaults for things like this. So especially if you're just testing out a service, so we're just playing with ECS right now, we're pretty safe with that, with those defaults. The same goes for resource usage. In any case, we're good now, so we're going to move on to configuring our ELB. They're like closing this Amazon building around me. So this is going to walk me through a wizard, which I'm a big fan of for things that I've never tried before. You have a couple options here. So you can have non-load balanced. We're going to walk through the load balancer, even though it's pretty. I don't really need to load balance my traffic in this, but I think ALB is pretty cool. So why application load balancer instead of the ELB classic? I feel like I've been talking about this a lot lately, but my big things for ALB is that one, you get some extras there. So there's a little bit more extensive logging and CloudWatch monitoring this way. My big thing, honestly, is 2 things. One is efficiency. So I can use that same application load balancer to route to multiple paths. So basically, what the ALB is letting you do is route traffic based on path. So I can send some requests to /web and some requests to /API. So that is magical. And it also means that I can use that one application load balancer can handle multiple things. Where previously, the ELB, so ELB Classic, I basically ended up with one load balancer per service. So not super efficient. Now I can replace multiple ELB Classics with one ALB. Definitely recommend ALB for ECS. I think they're a really nice fit together. I think the coolest and maybe I don't think it's talked about it enough, but something really cool that ALB lets you do is this dynamic port mapping. So when you're deploying things to ECS, technically there's 3 constraints, right? So there's CPU and there's memory, but then there's also port. So if I have an app and it's like, we'll call it my like API app, and it runs on port 8081, there's only one port 8081. So I only get the one. I can't make more of them, and what that means is that I'm constrained by that port. So since I only have the one, if I want to deploy multiple copies of my web app, I need at least enough instances that have that port available. So for example, if I just want to scale up my my messaging app, I have to, if I run out of boxes that have that port 8081, I have to start up a whole new instance just for that one, for my one service. Not a super efficient use of resources. We could do better. So what we can do with ALB though is that we can allocate those ports dynamically. So we can stick with our same container port, but we can map it dynamically to the host port. So if I leave that as 0 in my task definition, it'll use whatever port it can on the host and just stick with that same container port that we exposed in our Docker file. So it's pretty magic, and it actually, the big thing there is that it removes one of our resource constraints. So now I'm only constrained by actual like physical requirements, so CPU and memory. I can't make more of those on the box other than using bigger boxes. So when I'm picking the instance to allocate my task to, I only have to worry about whether it has enough CPU and memory as long as I can use dynamic port mapping. So really cool. There's a bunch of documentation about this also, like there is about everything. Iamba mentioned in the chat that AWS has some pretty extensive documentation on the services. This is true. This is just like kind of like a little preview walkthrough type stuff. I think I say this every week, but if you're running this in production, read the documentation. This is just a demo. So before running any of this in production, definitely look at the available settings, definitely customize things if you need to, definitely make sure that you're setting sensible resource limits, all that good stuff. So without further ado, we will jump on to our load balancing. So this is our container. It's going to help us a little bit. So it's defaulting, and you'll notice that it's defaulting to our application load balancer now. And that is because we very much recommend that you use that with ECS. So I already have this IAM role set up because I walked through the first run wizard. So here's my ECS service role. I have my ELB name already. It's ECS demo, and I can select my container. But what if we didn't have my ELB set up? That is different. Oh, and I already have this tab open. And then so if I go to load balancers, we'll see my little spinning wheel of progress. Hopefully it hurries up. Cool. So let's create a new load balancer so that we can walk you guys. It'll be a short stream today because I've already kept you guys much later than usual. So we'll probably walk our way up through the application. We'll probably walk our way through the application load balancer creation, and then hopefully we have time to finish. But if not, we will recap all of this next week. Cool. So application load balancer. We continue. We're going to name this Twitch. You have 2 options here. So you can make this internet facing or you can make this internal. We are going to make ours internet facing because we want people to actually be able to hit our app from the internet. If you have a service though that's only used by your company internally, you can use that. You can use both IPv4 and IPv6. So here's where, remember when we were making our task definition, so we need listeners, right? And if you've worked with ELB Classic before, a listener is basically how you can communicate with the load balancer. So if you have a secure listener, it'll be HTTPS, it'll be on port 443. If you're using a non-secure listener, it'll be on 80, which is just the HTTP port. So we only made our app, and again, the caveat that this is a demo, we only are using port 80. That is not secure, but we don't really care in this particular thing because it's just a demo. Again, though, in production, always have a secure listener. And actually, you don't even need a non-secure listener. If you have the right SSL certificates, if you have the right setup, you don't even need to allow insecure traffic, which I think is money. Okay, so we're going to add all of our availability zones. So we add them by subnet. I picked the wrong, there we go. So I have to do this. So I've created my availability zones. I have my internet gateway. So this is really it so far. And I get this warning, right? So Amazon is going to tell you the same thing that I'm going to say, which is use a secure listener. We're going to ignore this. Don't ignore this in real life, but it's fine to ignore this for this demo. We know that it's not secure. So we're going to power through, but it's good to use. Generally, we always want to use that. We're going to use the load balancer ports that we created last time. You could create your own security group. This is the part where it's a little different maybe for an ALB as it is for an ELB. These target groups are how path-based routing works. So you can see, look at the help text here, because I don't know about anybody else, but I sometimes get a little confused between what's happening on my load balancer ports and what's happening in my instance security groups ports. So this is what you want to look at here, though. So I'm going to add, so port 80 is the port that my load balancer has. So I'm going to name this Twitch again. Actually, we don't have to name it anything. We can just name it test. And here's why. So next, oops. Well, so we're going to add our 2 instances. So here's why I did test, by the way. Oh, thank you for everyone commenting that I sneezed. Iamba said, I did this a while back for production, and it was my first time doing it. We had an SSL certificate, which I imported, so it's interesting to see how much I got wrong. Same here. So when I first set this up, I messed up a bunch of stuff. And anyone that I used to work with will tell you that I am stingy about ports. So I always, where we're adding all these new services, the thing that I always forget to do is expose that in the security group. So then I'm looking at it and I'm like, oh gosh, like this doesn't work. I don't know why it doesn't work. And the answer for me is 95% of the time that I did not expose the port. So learn from my mistakes. We're gonna go ahead and create our load balancer. The reason that we have this, the reason for this is going to become clear. So we just added our Twitch test little target group. You need at least one target group when you're creating your load balancer at the beginning. But we don't know everything about our app yet, so we're just gonna go like this. Our load balancer was successfully created. You'll see that it is still provisioning. Sometimes this takes a couple minutes. So we have to wait for this to finish though before we can actually use it. I'm gonna keep just hitting the refresh button, even though I know that it won't make it any faster. Makes me feel like things are happening, even if they're not. Hopefully this is a little bit quicker. It's not, it's gonna take forever, I just know it. Anytime I'm doing something live, I'm doing this and no one's watching, I'll be like, done. Load balancer created. If I'm doing this on Twitch, it'll be like, I'm not done yet. I'm still not done yet. hopefully this hurries up, because I would like to actually use this, and I feel bad because technical problems have kept people. Yes, so Raise 195 says the demo effect. That is true. All live demos eventually have this issue. So we'll hang out for a couple minutes and wait for this and see if it can happen. If it looks like it's going to take a while, I can let everyone go, because we're already way over time. But hopefully we'll be off to a smoother technical start next week. If you're just joining me, all we've really missed so far today is a lot of technical glitches. So we started very late. The original intent for today was to deploy our task definition in our new service and then test whether our app worked or not, which we thought maybe it wouldn't, and then we'd have to fix it, which is fine. Iamba says, what's the artwork behind you? I don't know. It looks like a palm tree though. Yeah. So I'm working in the Amazon loft, so I assume that is going up on a wall somewhere, but I could not say for certain. So we're still waiting on our VPs, on our ALB to provision. We've recapped what we've done the last couple of weeks. So we've created our Docker file. We've learned about a couple Docker commands for pushing, tagging, and building and running our Docker containers. We pushed our container to our ECR registry a couple weeks ago. And then the last time we streamed, we did a bunch of this AWS setup. So as you can see, we still have some more AWS setup left, but we talked about how to make task definitions and container definitions, and we created our Twitch MTA task definition number 1. So we have one revision of our task definition. We've created our cluster. We have instances that are provisioned to that cluster. And now we're trying to create our load balancer and add our target group so that we can create our actual service using our task definition from last week. I am still waiting, obviously, for my load balancer to catch up with us. Hopefully it's not more than a couple of minutes. If there's any questions, I'm happy to take questions now. And then Emma says, goodness me, the provisioning time. Yes, I think our stream today might be kind of cursed. I don't know if I believe in curses, but maybe I do now. Definitely the demo effect. Awesome. So this is active. So we're gonna see if we can power forward with this. So yep. So we have our new Twitch demo, which is in our new Twitch ALB, which has now showed up in our ELB dropdown list. You can see that I picked dynamic port mapping when I did my container and task definitions because it has a 0 here. So it goes in the order. It's the name, the host port, and then the container port. So remembering, Amba, no one's cursed, hopefully. Maybe we're all cursed, I don't know. So we'll remember that when we created our first, the Docker file for our original Python app, we exposed the port. So that port is the container port. So that's the port we're exposing here. And then 0 is how we get dynamic port mapping to work. And then, okay, so here's the step that I was about to forget to do, but then the console notes rescued me. So what showed up here was we have that blue button that said configure this container with ELB. So that's how we set this up to have its own target group. We're using 80 because we only have that one listener port. If you needed a different port, so if you were using like WebSockets or TCP or something and you needed to add a new listener to work with your container, you can do that at this point. It'll help you create the target group. So we're just gonna let it create its own name for things. I think that's fine. So we're gonna do this, and then we're gonna make it 1. We don't have a specific path here. So we want basically everything that matches /, so all paths, to go to our is the 7 train running app. That is not the case for some more fully functional apps. You might have different paths, or you want traffic to only hit /web. So we are going to do just that. Cool. So we've configured our paths. We're going to health check against / also because we have not set up a different path. At this point, it's telling you that we're good. So we've picked our task definition, we've picked the cluster to deploy it into, we've named our service, we've set the number of tasks that we want, we've set a minimum and maximum healthy percentage for deployments, we've chosen our task placement strategy, and then at this point we have 2 optional configurations. The first one we've already done, so we've chosen to configure and register our service with an ALB. At this point, you could also do service auto scaling, and we'll go back and look at this a little later. But at this point, I can choose how I want to scale my service up or down. For example, if I want to go by number of requests, I can scale my service up. If I get like over a certain number of requests, I can choose to scale my service up, and then what goes up must come back down again. So I have to scale my service back down after that. I actually got a question about this last week at the ECS booth at DockerCon, where someone was like, hey, this doesn't work. So my auto scaling doesn't work. And what he had done is that he had put kind of the minimum and the maximum at the same number. So I don't remember what the actual the rule was, but he was basically scaling up at like 80% CPU and then back down at 80% CPU also, which didn't look like it at first because but he was using greater than or equal to. So he had scale up when the CPU was greater than or equal to 80, and then scale back down again when it's less than or equal to 80. And this is also probably something, be like, oh, well, I want to take an action at if it goes under this number, I want to scale back down. And yes, but you want to leave yourself some wiggle room also. So when I scale up, that's good. And if I'm scaling up at greater than 80 CPU, that's fine. But I also don't want to flap. So I don't want those numbers to be too close to each other, because then they'll just keep going up and down and up and down and up and down and up and down. Or, as he was saying, it doesn't work at all when they share that common value. So it would be trying to scale up and scale down at the same time, which effectively means it's doing nothing. So fun fact, be sensible by your auto scaling rules. I try to do it so that there's like a section in the middle. So, and there's some reasons for this. So I scale up maybe at over 80%, and then I don't scale down again until it's less than 65. These are just some examples from some numbers that I made up. But basically it means that I'm scaling up in response to like high traffic or high CPU or basically high resource usage. But then I'm not scaling down again right away. So that's saving me from scaling up and down, because it takes a second to scale, right? So it's not like instantaneous to scale. So if I scale, so I go up and then I like wait a little bit, and then IAMA says I use the same numbers, 80 and 65, 80 and 60. Those are good numbers. I like them. But I wait a little bit to scale down, which saves me from having to like scale right back down again, like just at 75 or something, and then go right back up if my traffic gets high again. So fun fact, we're creating our service. You'll see that we had things that were already done. So like our IAM service policy was already created. And then we could view our service. So what this is going to try to do right now, and it said no container instance met all of its requirements. So now we can troubleshoot. I'm going to guess it's because we have no instance open that has the right. So you can see that I definitely don't get anything right on the first try. So let's go back and look at our cluster and see if we can figure out what's going on with it. So what's happening on the 7 train? This is why. So we'll try to add some instances. I wonder what's happening. So let's view our cluster resources. Desired number of instances. Sweet. Wonder what we've done here. Let's look at our auto scaling group and we'll see what we've done. Okay, so let's edit it. I want desired 2, minimum 2. Let us see why we have no instances. Okay, so I have 2 instances, and then let's see why we can't. Oh yes. Can you see the full screen now? Oh, wait, this is an OBS setting problem again, I think. The answer is yes, I can if I can figure it out, which is not always possible. So hopefully you can see a little bit more of it. Okay. It might be kind of small in order to see everything going on right now. So we have our instances that are happening, and now we need to figure out why they are not registered to our actual cluster, which I guess is fun for us. What are my cluster resources? Let's look at my instances. And it's still saying that we have none. So let's find out why we don't have any. Twitch demo. So let's try, we have this. Try dragging. I did do that. Perhaps this is better. Twitch, we have 2. I feel like the stream is in 4.3. I don't know what that means. What does that mean? Oh, the aspect ratio. That is possible. I maybe need to see if someone from Amazon will help me with OBS, because I feel like I have settings wrong like a lot of the time. So I'm not really sure why that's happening. But let's see if we can get this working. Okay, so we've created our service. So let's see if we have any tasks happening right now. Okay, cool. So we have pending. So basically, you get a couple statuses in ECS. Yes, I will see if Randall will help with my OBS settings. Maybe it will be Randall to the rescue. I believe he's at serverless conf right now, probably talking about Lambda, which is cool. Okay, so what happened? So we had a failed deployment. So I think what we're going to do is, okay, so this means our deployment is not quite working. So we had to figure out why it's not working. we are already half an hour over when we're supposed to be streaming, so I will probably end up here, and then we will talk about how we can go troubleshoot our ECS cluster. We'll talk about how we can troubleshoot our ECS cluster. With that being said, let's recap what we talked about today. So we talked about how to create the target groups in the ALB. We talked about the target groups. We talked about how we do path-based routing, and then some reasons why we want to use ALB versus ELB, which is the classic load balancer. But basically, we want dynamic port mapping, and then we also want we talked about different listeners. So when we want 80, when we want 443, and why my little demo app is not safe because it does not use 443, it uses 80. So we talked about our ALB setup, we talked about target groups and path-based routing, and then we caught ourselves up to speed for everyone that's just joining us on what we've covered the last couple weeks. And then we had a lot of technical difficulties. We will pick up our troubleshooting. We'll tweet, I think, with the exact time for this, because we'll do the whole thing again. So basically, we learned how to register our ALB to our service, and we deployed our service, but it's not quite working. So next week, we're going to play Twitch Troubleshoots AWS, which is fun. So once we've troubleshooted why our container isn't starting, then hopefully we'll get a successful deployment, and then we'll talk about some ways that we can improve our containers and our task definitions and our services, and some extras that you guys will want to set up on your own. So service auto scaling or better CloudWatch logging, etc. Cool. So thank you for sticking with me this time, everyone. I know that it was kind of a rough stream with some technical problems. Hopefully we get this all sorted so it doesn't happen next week. But thanks for being patient. I appreciate any feedback. If you stuck around, that's awesome. And we will be back next week to talk about troubleshooting and more fun stuff that we can do with ECS. So that is all. Thanks for joining us, everyone. I will catch you next week.